welcome to Scholars Forum again. Here I am at your hostel giving you the mathematics that some of you hate, but then you don't have a choice, you have to study it because without it your portal will show you blue. Alright, now today, or this particular session, we will be taking number system. And since this one does not have any calculation, I believe many of you would want to watch this one. So let me tell you now, this one does not have calculation, but then you have to understand the concept. Okay, so we are working on number system. Okay, so under this number system, we'll be looking at naturals. Sorry for my handwriting, that's how I write when I'm rushing. Naturals, we have the integers, we have the rationals, we have the irrationals, we have your reals, and we have your complex. Yes. Alright, so each of these sets of numbers have numbers that represent them, like this, the natural. Okay, we have the integer. Okay, let's rewrite that again. Alright, we have the rationals. Okay, we have the irrational, which basically does not have a symbol. Okay, and we have the real numbers. Then we have the complex numbers. Okay, now what exactly separates each of these number systems? Now, the natural systems, many of you agree that our natural counting numbers are 0 to 9, correct? Okay, now do not forget that each of these numbers undergo addition, subtraction, division, multiplication laws and operations. If you observe, when you subtract a 1 minus a 1, it gives what? A 0. Now, initially, 0 is not a counting number. Okay? But then, under natural numbers, alright, we have 0. So for natural numbers, we have them being equal to 0 down to 9. Okay? But then, there is something we call the n plus. What is the n plus? Now, since we are talking about addition, okay, that means we cannot be adding 0 plus 0. But we can add 1 plus 0, we can add 2 plus 0, 3 plus 0. Okay? Now, 0 cannot be negative and cannot be positive. In that sense, we cannot add 0 in the n plus group. So we're starting from 1 all the way down to 9. Are we good? Now, that is all under natural numbers, clear existing numbers from which every other counting number comes from. Now, integers, okay. Now, pending the fact that so the subtractions of these words sometimes might give us negative numbers. Take for instance, you have 2 and you have 5. They are natural counting numbers, okay? But if you do 2 minus 5, it will give you what? A minus 3, okay? Now, can you observe that minus 3 is not the natural counting numbers? That gives room for the next kind of numbers that we call the integers. The integer is any group of the set of numbers that contain both negative, okay, negative infinity, alright, okay, down to positive infinity, okay. So let's take, for instance, minus 2 down to plus 100, okay. So this is all these are integers. So where you have your minus 6, minus 8, minus 12, 48, 792, 5 million, and the rest. Please, if you can do 5 million transfer for me, please do. I'll drop my account details under the comment section. Alright, so these are integers. Okay? Now for rational numbers, take for instance now for natural numbers, for integers now, imagine we have 20 as an integer divided by 6, which is also an integer. Okay? Now, what's the problem with this work? No problem with the work, alright? But 20 divided by 6, it's only equals a 3 point something at the end of the day. Now, do you see any group that has anything that has to do with a 0.6? No. That gives us room for the next kind of numbers we call the rationals. Now, the rationals are what? Numbers existing in both fractions and decimals, basically. Okay, so natural numbers from instance 16 over 3, alright? For instance, 3.142. All right. Now these are natural decimals. Okay. They are all recorded under what? Under rationals. Okay. Now they are irrational. One thing with the rational is that it has a definite end. Okay, the rationals have what? A definite end on the decimal points. Okay, now a 3.142, as the pi calls it, we call this the short form of it actually. Now the extended version of 3.142 is long, so we could actually say that 3.142 could actually be irrational. Alright, but what we'll be writing here to be rational is 22/7. So 22/7 in this case is rational. Alright. But then when you go into irrational, they are unending decimals. Okay? Take for instance, 10 divided by 3. This will give us 3. So you see, when a number like this does not end, okay, we call them irrational numbers. Alright? Now, what do you talk of real numbers? Now, the combination of all the rationals, irrationals, integers, naturals, all of them combined, we find them into what's the real number. Real numbers are very express numbers that can be identified. Once you see a real number, you know it's a real number. Okay? Those are what we call real numbers. Now, what are complex numbers? These are ones expressed as imaginary. Okay? They are represented with letter I. Alright? So the letter I shows that this number is actually what? Complex. So, yes, continuing from this end, we said whatever number that cannot be expressed as real, okay, has to be expressed as imaginary. Okay, and yes, all real numbers are additions of what? Your rationals and your irrationals. Okay, now for complex numbers, how exactly do you identify them? Okay, now when you are defining a complex number, whatever number that cannot be simplified, okay, to give a real number is what we call complex numbers. Take for instance, the square root of -1, which is not possible. We can't take the square root of a negative number. Okay, so that was why complex numbers was generated where I is equal to the square root of -1. Okay, so if I'm taking the square root of probably -4, alright, that means we can divide -4 into two places. Square root of -1 times the square root of 4. Okay, so when -1, square root of -1 is what? I. Square root of 4 is 2. Therefore, the answer to this one is what? 2 times I, 2I. So in this case, in this instance, you have seen how complex numbers are actually viewed and actually used. Okay? Negatives of square root of negative numbers. Okay? At the end of the day, you get this kind of answers with an I at the end. Alright? So in that instance, you have definitely seen the whole classes of numbers that we have, the naturals, okay, the integers, alright, the rationals, the irrationals, the reals, and the complex. Now let's see what more we have here to discuss. So we have an increasing order, alright, of these things, okay? An increasing order of these classes of numbers. Now what you are seeing here is the direct increasing order. So from natural numbers, we have the next set of numbers to be integers, the next set of numbers to be the rationals, the next set of numbers to be the real, and the last set of numbers to be the complex. So at the end of the video, you will find out that all numbers, no matter how big, no matter how small, no matter how short, no matter how long, all fall into the three parts: real numbers and complex numbers. Okay, now going further from here, the last part of this particular topic is even numbers, odd numbers, prime numbers, and composite numbers. Now, this is not new to us. Even numbers are numbers that can actually be divided by 2, okay, without a remainder. So when they are divided by 2 without a remainder, okay, that makes it an even number. And now for numbers that are not divisible by 2, okay, or that possibly will be divided by 2, but they still have a remainder, are what we call odd numbers, okay? So 2 don't divide these numbers completely. Alright, we call them odd numbers. Now the last one, but not the least, is prime numbers. Prime numbers are numbers that have just 2 factors, 1 and itself. Okay? 1 and itself. Prime numbers, just 1 and itself. Now the last part of numbers is the composite numbers. These are numbers that have more than 2 factors. Once a number has more than 2 factors, automatically that becomes a composite number. Take for instance, let's see, 14, alright? So we have 1, we have 2, we have 7, and we have 14. Okay, so how many factors do you find here? 1, 2, 7, and 14. Therefore, this is a composite number. 14 is a composite number. It is not like number 7, where the only factors we have for 7 is 1 and 7. 7 is what? A prime number in this case, because it only has 2 factors, the 1 and itself. But then you're looking at 14. 14 has up to 4 factors here. 1, 2, 7, and 14, making it a composite number. We have come to the very end of number systems. This is all under number systems. Hit up and be ready for the next session as we'll be taking the next one very soon.